Hi there. In this video I'm going to be using the PhET simulation forces in motion basics in order to go over Newton's first and Newton's second law. So what is Newton's first law? It says when the forces acting on an object are balanced, the object will remain at rest or continue to move in a straight line at constant velocity. So why don't we set that up with balanced forces? So these guys are going to pull to the left, these guys are going to pull to the right, and if I click up here, I can see the values, and the total force to the left is 350, the total force to the right is also 350 newtons. These are balanced forces, equal in size but opposite in direction. That means that when I sum the forces, it adds up to a resultant force or unbalanced force of 0 newtons. What I'm also going to do is I'm going to look at the speed of this trolley in the centre and click go. And of course the speed's 0, it remains stationary when the forces are balanced. What I could do is I could unbalance the forces just for a fraction of a second. I'm going to remove this little person here, and that would mean the force to the left is slightly greater for a fraction of a second. The forces will be unbalanced, so hopefully the trolley will accelerate to the left, and then I'll put that person back in, like so. Now at this point, forces are balanced again. And since the trolley was already moving, with balanced forces it now continues to move in a straight line with a constant velocity. So as we said, when the forces acting on an object are balanced, the object will remain at rest or continue to move in a straight line at constant velocity. And if I wait a fraction of a second, then hopefully the blue team, there we go, the blue team win. Return that to the centre. Now Newton's second law. That says when the forces acting on an object are unbalanced, the object will accelerate. So let's remove, I think we'll remove some guys from that side there. There we go. Now we have a total force of 350 to the left, 250 to the right. So we have an unbalanced force of 100 newtons to the left. So click go this time. And of course, what is happening is, if you look at the speed dial, it's increasing. We do have an acceleration to the left. So that's in the direction of the unbalanced force. The other thing, of course, that Newton's second law says is that the object's acceleration is directly proportional to the unbalanced force acting on it. So if I return these guys to the centre, and if I have a greater unbalanced force to the left, then hopefully the acceleration to the left will also be greater. Let's see if that works. And of course the speed dial is increasing at a far greater rate. So the greater the unbalanced force, the greater the acceleration. And I can show Newton's first law and Newton's second law just using this first screen. There are 3 other screens in this simulation you might want to try. This one here labelled motion. Now this doesn't include friction. I can apply a force to the right on an object which is placed on a skateboard. I can change the object that's placed up there. I can look at the force, the mass and the speed, and you can see that I've got an unbalanced force to the right. Let me just pause it there for a second. I have an unbalanced force to the right, and of course that means that therefore the object accelerates to the right. Get it started again, because I know that once the speed gets up to 40 meters per second, the force is no longer applied, and that's going to happen right now. So with no force applied, and of course there's no frictional force acting on the skateboard, then of course what's happening is the object continues to move at constant velocity. That's from Newton's first law. So while there was an unbalanced force acting on it, it accelerated. When there's no unbalanced force, it remains either at rest or moving at constant speed in a straight line. This next screen incorporates friction. So what I can do is I can apply a force again. Now at this point the applied force is equal to the frictional force but in opposite directions. So I have balanced forces, and of course at this point it's not moving. Increase the applied force, the same thing's happening. Increase it again, and now the applied force is greater than the frictional force. I can actually look at the size of these forces. I've got 150 to the right, 94 to the left, and that means the unbalanced force must be 56 to the right. I can also look at the masses and the speed, and of course because I have an unbalanced force acting to the right, then of course the object's going to accelerate to the right. Again, once that gets up to 40 meters per second, that pushing force, the applied force, is going to be removed. Let's see. There we have it. But, of course, at this stage, the object's moving to the right, but of course friction always acts in the opposite direction to motion. So because we have a frictional force in the opposite direction to motion, the object is now decelerating. Now there's one last screen that you might want to look at, and that's this one here, which says acceleration. And you can try changing the object that's being pushed. You can change to this bucket of water or one of these two people, or a fridge, or whatever you want. I'm going to apply a force like so, just as I did before. Make that slightly bigger. I'm going to look at the sum of the forces, the values, masses, speed, and I can also look at acceleration as well. Now, if you want, what you could do is you could work out the acceleration. I know I'm being told here that it's 2.12 meters per second. I could use Newton's second law, and there's an equation which goes with that, F is equal to ma, in order to calculate that equation. In fact, what I could do is I could untick acceleration, and I could use the values on screen in order to work it out, and then tick to check if I'm getting the correct value. So how we would do that, if I have a force, in fact I could even uncheck this to start with. If I have an applied force to the right of 200 newtons, and of course a frictional force to the left of 94, then of course the unbalanced force would be, I could apply something known as Sine Convention. I could say that the forces to the right are positive and the forces to the left are negative. So of course my unbalanced force would be 200 plus minus 94, which would give me 106, and that's the unbalanced force to the right. And therefore, using Newton's second law, F is equal to ma, rearrange that to give me acceleration A is F over m, is 106 divided by the mass, which is 50 kilograms, and that should give a value of 2.12 ms to the minus 2. Get that started again. And of course, after it reaches 40 meters per second, that push force is no longer applied. And what then happens is I have an unbalanced force in the opposite direction to motion. Pause it for a second, because I could again work at that deceleration. So from A is equal to F over m, the unbalanced force is now in this direction, which is the opposite direction to motion. I could take that as a negative force. Negative 94 divided by the mass, which is 50, and that gives an acceleration of negative 1.88. Again, worked out using Newton's second law. There's lots to play with in this simulation. As I said, 4 different screens that you can look at, some of them incorporating friction, some of them not, but perfect in order to look at Newton's first and Newton's second law. That's us for now though, and we'll see you in the next video.